Welcome to the Foundry by Forge College. Today we're taking a massive leap in our journey to understand Web3 architecture. We are finally stepping out of the theoretical wilderness, and let me tell you, I was definitely feeling a bit lost out there, and we're stepping right up to the drafting table. Have you ever looked at just a massive pile of raw, complex data and thought, how on earth do I make sense of all this? Well, we're fixing that today by transforming all that heavy Nakamoto Consensus data into a crystal clear, structured blueprint.
So to really understand where we're going, we kind of need to look at where we are in the overall Bitcoin fundamentals track. In our last explainer, we were deep in the trenches, right? We were crunching the heavy math, evaluating security, mapping threat models. It was incredibly dense. But today in step 2, we transition from that heavy evaluation phase over to the synthesis phase. We're taking those raw, chaotic numbers and drafting the ultimate comparison table. This table is absolutely going to be the backbone of the capstone analytical report we're going to write together in step 3.
All right, here is our engineering schematic for today. We'll go from data to blueprint, break down the anatomy of the table, synthesize the evidence, automate the assembly, do a strict quality control check, and finally, prepare the capstone. Let's get to work.
Section 1. From data to blueprint. It's time to become the architect.
Think of all that raw data we generated in our last session as just scattered building materials. We've got piles of probability curves, heaps of threat matrices, orphan rates floating around everywhere. Honestly, it gives me a little bit of anxiety just looking at it. It's pure chaos. But the profound relief comes when we step into the role of the architect and literally snap these disjointed facts into a beautifully structured artifact. It's like putting together a giant puzzle.
Section 2. Anatomy of the table. Let's look at the structure of our blueprint.
Before we start pouring any concrete, we absolutely need to understand our structural components. And the most crucial concept here is a reproducible artifact. What does that actually mean? Well, it means your documented output explicitly links your claims to verifiable data. If someone else, literally anyone, looks at your blueprint, they should be able to recreate your exact conclusions from scratch. Why is this our ultimate goal today? Because in engineering, and especially in Web3, trust requires verification. We don't just ask people to believe us, no way. We show them the math.
And this right here perfectly illustrates the difference between a weak foundation and a strong one. Over on the left, we've got this flimsy qualitative claim. Proof of work is secure, trust me. In a real analytical report, that statement will completely collapse under any kind of serious scrutiny. But on the right, that is a load-bearing pillar. Proof of work at tax success probability equals 0.002. Qualitative claims are, frankly, practically useless without the quantitative metrics to back them up.
So here is the bare skeleton of our drafting schematic. We start with the feature of the consensus mechanism, followed by the specific evaluative criterion. Then we link the raw evidence file. Next, we explicitly state the benefit, and crucially, its paired trade-off. We lock that down with a supporting metric, and finally, we note a future implication for further study. Every single column here serves a distinct structural purpose.
Moving into Section 3, synthesizing the evidence. Time to start snapping things into place. Let's lock in our very first feature, proof of work. We're measuring the criterion of security versus cost, pointing directly to our confirmation probability plot as our hard evidence. Now, notice how the massive benefit here, which is a highly expensive 51% attack, is immediately paired with its trade-off, immense energy consumption. And we anchored this entire thought with hard math. We show that an attacker's success probability, assuming 30% hash power after 6 confirmations, is just 0.002. That's a strong claim.
Building right on top of that, let's look at our second row, probabilistic finality. Our criterion here is finality confidence, and our evidence, that links straight back to our confirmation table CSV. The core benefit of probabilistic finality is that it scales beautifully without needing some highly complex finality protocol. It just gracefully degrades, but the trade-off, you don't get instant absolute finality. You actually have to wait for confirmations, which we prove using our probability curves mapped against confirmation depth.
And finally, we snap the third required piece right into place, network propagation. Here we're looking at consensus stability, citing our orphan rate report CSV. The benefit is that these simple gossip protocols allow for incredibly wide network participation. The trade-off, though, is that those propagation delays naturally increase the risk of orphaned blocks. And our supporting metric for this, a highly specific observed average orphan rate of 1.2%. Do you see how everything is tied together logically?
Section 4. Automating the assembly. Let's spin up the programmatic line.
Now listen, we could type all of this out by hand, but manual data entry just invites human error. It's too risky. So we trade that manual labor for a programmatic assembly line.
which is honestly a super common theme across the courses at Forge College. We achieved this automation using a really compact Python and Pandas script. The factory line logic is surprisingly simple. First, gather your evidence files into a folder. Second, define your table schema using Python dictionaries. Third, populate those rows into a Pandas data frame just to ensure structural consistency. And fourth, instantly export pristine CSV and Markdown files. It's clean, it's repeatable, and it's fast.
I gotta say, there is a profound satisfaction when you finally run that script and see this exact output pop up in your terminal. It's like magic. You've instantly generated a perfectly formatted, machine-readable CSV for your data, plus a human-friendly Markdown snippet that you can literally just drop directly into your text editor. No formatting headaches, no messing around with spacing, just pure, verified output.
Section 5, Quality Control Check. Time to play the building inspector.
All right, it's time to put on our building inspector hard hats. We need to look critically at the table we've just built and ask ourselves this single, completely uncompromising question. Does your evidence actually support your claim? Because I'll tell you right now, if the specific numbers in your table don't match your source data perfectly, your entire analytical report completely loses its credibility.
To guarantee that structural soundness, we use a very strict pass-fail inspection checklist. First, verify the files actually exist in your directory. Second, check that every single required column is complete. Third, physically open the evidence links to validate they're pointing to the right charts. And fourth, this is the big one. Randomly pick a metric from your table and recompute it from the source data. If it doesn't match, you fail the inspection and you need to rebuild.
Section 6, Preparing the Capstone. Handing the blueprints over.
Okay, our blueprint has officially passed inspection. Now, as you prepare to translate this beautiful architectural document into the actual narrative paragraphs for your final report, I need you to burn these 3 golden rules into your mind. Number 1, tie every single claim to a named evidence artifact. Number 2, always express your security properties quantitatively. And number 3, present your trade-offs as paired observations. Remember, every single benefit has a measurable cost. If you follow these rules, your report is going to be unshakable. So I'll leave you with this final provocative thought to ponder. How will this meticulously crafted blueprint actually shape the flow and the narrative structure of your final analytical report? The hard work you've put in today dictates exactly how you're going to tell the story of Nakamoto Consensus in our next explainer. It's going to be an incredible drafting process. I highly encourage you to visit forge.college to continue your Web3 architecture journey, get access to more learning materials, and dive even deeper into this track. Keep building, keep verifying, and I'll see you in the next explainer.